Hello everyone. In today's lecture, we are going to discuss one of the most exciting technologies in modern orthodontics, that is 3D printing. Over the last decade, 3D printing has revolutionized the way orthodontists fabricate study models, clear aligners, retainers, indirect bonding trays, surgical guides, and many other dental appliances. Instead of waiting days for a laboratory to manufacture a model, clinicians can now produce highly accurate dental models within a few hours in their own clinics. Now, in today's lecture, we will cover what is a 3D printing, history of 3D printing, how a dental 3D printer works, and types of 3D printers, components of 3D printers, printing workflow, applications in orthodontics, advantages and limitations, maintenance, and lastly, the clinical tips. So, first of all, we will try to understand what is a 3D printer. So, a 3D printer is a machine that creates a three-dimensional object by adding material layer by layer from a digital design. Unlike traditional manufacturing, where material is cut away from a solid block, 3D printing is an additive manufacturing process. So, in dentistry, the digital model is first obtained using an intraoral scanner or a laboratory scanner, and the model is saved as an STL file, then prepared using a slicing software and then sent to the 3D printer. And then the printer builds the model layer by layer by using a light curable resin. And and this technology has significantly improved the speed, accuracy, and efficiency of digital orthodontics. The concept of 3D printing actually began in the early 1980s. In 1984, Charles Hull developed stereolithography, the first commercially successful 3D printing technology, and he later founded 3D System, one of the pioneers in additive manufacturing. And initially, 3D printers were expensive and used mainly in engineering and industrial design. As the technology matured, cost decreased, and dental applications expanded rapidly. Today, 3D printing is routinely used in orthodontics, prosthodontics, implant dentistry, oral surgery, and maxillofacial reconstruction. And modern desktop printers allow clinicians to manufacture high quality dental model directly within their clinics. The basic principle is simple. A digital model is divided into hundreds and thousands of thin layers of slicing software, and the printer then fabricates one layer at a time until the complete object is formed. And for resin printers, ultraviolet light selectively cures liquid resin according to the digital design. After one layer is cured, the build platform moves, allowing the next layer to be formed, and this process continues until the entire model is completed. And the thinner the layer thickness, the smoother and more accurate the final printed model is. Let us see what are the types of 3D printers. There are several types of 3D printers available for dentistry. First of all, and historically, also the first to be developed was the stereolithography. SLA printer uses a laser beam to cure light liquid resin layer by layer, and they provide excellent accuracy, smooth surface finish, making them suitable for dental application. The example includes the Form Labs Form 3B Plus. Next is the digital light processing printer, that is DLP. DLP printers cure an entire layer simultaneously using a digital projector. This makes them faster than the SLA printers while maintaining the excellent accuracy. These printers are commonly used for orthodontic models and surgical guides. Then we have the LCD or MSLA, masked stereolithography. LCD printers uses LCD screens to mask the ultraviolet light while curing resins, and they are affordable, fast, and widely used in dental clinics. Popular example include the Eligo, Saturn, Anycubic Photon, Monroe, and Frozen Sonic series. These printers have become the preferred choice for in-house clear aligner production. And then lastly, we have the fused deposition model, that is the FDM model. The FDM printers use metal melted plastic filaments instead of resin. Although inexpensive, they lack the accuracy required for clear aligner models and are generally not recommended for orthodontic applications. Then we have to understand what are the components of the 3D printer. That is, every resin printer consists of several essential components. That is, first is the build platform, then we have the resin vat, that is the tank, then FEEP or ACF film, then ultraviolet light source, LCD screen or laser projector, Z-axis monitor, guide rails, touch screen display, cooling system, power supply, USB, Wi-Fi connectivity, and controlled software. So each component contributes to the accuracy and reliability of the printing process. The digital workflow follows these steps. That is the intraoral scanning, export the STL file, import into slicing software, orient the model, add support, select print settings, slice the model, transfer the file to the printer, print the model, wash in isopropyl alcohol, remove support, UV cure the model, inspect for accuracy, and thermoform the aligner. So every step is important. Errors at any stage can affect the fit of the final aligners. Coming to the application in orthodontics, dental 3D printers are widely used to manufacture clear aligner models, orthodontic study models, vacuum forming models, Essex retainers, surgical guides, indirect bonding trays, occlusal splints, sleep apnea appliances, mouth guards, diagnostic models, and this versatility has made them an essential part of the modern orthodontic practice. Now, high accuracy advantages are that they have high accuracy, rapid production, excellent surface finish, digital workflow integration, reduced laboratory dependence, uh, lower long term cost, easy storage of digital files, and quick replacement of lost aligners. But there are certain limitations also. For example, initial equipment investment, resin handling requires care, regular maintenance is essential, and printing failures may occur with incorrect settings. So this was the basic information about what are the different types of 3D printers and which one is being utilized in dentistry and especially for making aligners. So hopefully the information was of use to you. Thank you.